that's the inner structure of the new tone arm. This is the inner tube, that are the bonding elements, and they are bonding the inner tube to the outer tube with these hundreds of structure elements. And you cannot do that by milling, drilling, die casting or whatever, so that's a very new production system, and the result is a very stable, light and very dampened arm tube, which you cannot get with any other production method.
So what is the production method? How do you do this?
It's done by stereolithographic laser sintering, which means you put a flat powder on the table, you use a laser to put that. The laser is heating up this area, so the aluminium is bonding together, and you put the next layer on. It's more or less like a 3D printer doing it in plastic, but a 3D printer has very wide gaps and it's not stable, and this one is done. Any step is 2/100th of a millimeter. That's the thickness of the powder.
So is this selective laser melting?
Yeah, but this is.
But it's different.
It takes forever.
Yeah.
And we tried several companies. The biggest problem is that we said, if you look at this or here, it's not only straight. It's then when it's getting to the contact zone, it needs to go out like on a tree.
Right.
And this is creating the stability, and there have been several companies which have been unable to do that, and we found one who is really able to. You can really see it's getting thicker at the end when it's where it's bonding, and that's such a fine structure. And this arm tube is light, not too heavy. It's very stable. It's
so you could make a 12-inch arm out of this and lose no rigidity.
Yeah.
Surprising. Oh
yeah.
My God.
Yeah. 12 inches the maximum, because this machine, as it is done slide by slide, the inner mounting area of the machine is somehow restricted. So 12 inch is the maximum which is possible.
That's fine.
And that's fine. That's what I said.
Now, what is the bearing system going to be?
It's a ceramic ball bearing. We tried ruby bearings also, but they are only 10% harder, and regarding the hardness, those bearings have to do nothing on the tone arm, so there is no wear or anything like that. But those ruby bearings are breaking even if you look at them.
Yeah.
So we decided to go for ceramic ball bearings, which are more rigid, have the same hardness, and are much better than the regular bearings. And so this will be quite something special, because everybody can understand and see that this technique is something very new, never done before.
Right.
It has really an advantage. This is not something you do that it's done. This is really a solution to a problem: stability, weight,
right.
and
damping.
And it's shocking.
When are you going to have a finished arm?
We will have that finished latest in September.
Because I mean, obviously this is great, but it's really a matter of how you implement it in the whole bearing system and the geometry and VTA adjustment. And how do you do and you do azimuth by loosening the clamp and turn.
This is right now not finally decided.
Right.
We are not sure if this is maybe a killer. Maybe we will have the head shell also done in the same process, so that it's one piece, and we maybe have the azimuth adjustment on the back.
Right, right.
This is simply something which we will decide after listening.
So this is really the main component. Now it's a matter of how you implement it.
Yeah.
And so you can't even begin to have a price until you...
I can tell you the price, because the price is clearly done. It will be, the 9-inch will be approximately about 17,000 euro, and the 12-inch will be about
20,000 euro?
Yes.
Wow, that's...
So that's not a cheap one.
No.
To give you an idea,
you could buy a car.
Yes.
But a lot of the stuff is the same price as cars. Yeah, right, exactly.
You know the calculation in the industry.
Yeah,
My costs on this arm tube, without any designing, developing, whatever, simply give them the file, let them do the arm tube, is about 1,200 euros. My cost.
Just
the
for
raw
that.
piece.
Yeah.
No milling, no drilling, no turning, lathing, no grinding, no surface treatment.
Right.
Nothing. So you can imagine that the material itself is freaking expensive, and this cannot be done. This arm will never reach the 5,000 or 10,000 euro area, because
right.
the idea behind it is this material is so expensive, and you can do it cheaper. Because, as I said, here the steps are 2/100ths of a millimeter. The normal steps are 2/10ths of a millimeter,
right.
which is factor 10.
10. Yeah.
So this takes forever. They need about 24 hours to build that tube.
One tube.
One tube in a machine. The cost of the machine is 3.5 million. So these machines are freaking expensive, and after them they X-ray it with a atomic whatever
to make sure that
to make sure that it worked also inside. Because also, if you look at this arm tube here, the structure is there at the front also, so it's here, it's longer, and then it's getting shorter and shorter, but it's still, until the front end, the structural elements are in.
It's there, yeah.
And you need to control that and make sure that it works. And so I think this arm tube is really something special, and the rest, I'm a little bit afraid that the rigidity of this arm tube maybe will be killed by this construction. So we check it, and if not, then the edge shell will be part of the arm tube, and we will have the azimuth adjustment either in the bearing on the backside, or we will have it here, because here the diameter is bigger, so
right.
we have more clamping area to get the stability back.
Okay, thank you.